8 million. Better make sure I put the brake on, folks. Oh, we've done over 10 million points. Hi, I'm Peter Haddock and I'm here at Rail Live with Ben with the IMS 3000. Ben, actually, what is the IMS 3000? It's on rails and it looks exciting. And I've seen this at the geospatial conferences in the past. Now it's here live at Rail Live. Tell me about it. What does it do?
It is indeed. So this is our 3D scanning system. So as you push this through any site, anywhere on the rail infrastructure, it's picking up a 3D point cloud for you, along with all of the track elements that are beneath you. So you're getting 2 million points per second, along with full track geometry.
We're on a big rail track here. We've got the sleepers, we've got the tracks, we've got even the connections here. And so we're picking up all of that. Now, point cloud, folks, for those who don't understand the point cloud, it's really tiny, tiny bits of data that we can't even imagine how many of those bits of data are in there. But every single element of that allows us to get a 3D model that is, you can drill right down to the tiniest speck, can't you?
Yep, we're talking millimetre accuracy on it.
Yep.
So if you are to scan, say, a platform or a tunnel for a structure, you have all that data then to carry on through. You can monitor your track with it, and you have that to pick up any pinch points where you might have a tight clearance.
Right.
And it just tightens up that maintenance. Rather than going through and having to do a big renewal, you are going in, you're going, this yard here is where our error is. We fix that, and all of a sudden, you can run trains at line speed again. So.
And the thing about this, folks, is we know the science works. We also know that when you've got that data, you then put it into a system of your own, which then can analyse that. So if we've got a tiny fracture here, or we've got something that's slightly off skew or whatever else, because that little maintenance bit, that can go into a system and then be analysed. And how does that work? So we've wheeled this down the track. We've got all that data which stored. Then where do we go with it, and how do we use it?
So there's a number of different places where the data can go after. It can go into any 3D CAD software. We can throw it into the Leica environment and use it there for analytical stuff. Onboard the Amberg software as well, we can run clearance profiles for trains. We can export platform edges, overhead line data, and our header rail data as well.
So let's talk a little bit, folks, about the bits, Ben. Because first of all, we start with this bit.
So here we have, this is the rail sense, void sense unit here, and then we also have the temp sense unit here. So the void sense will be picking up your dynamic load as a train runs over, the track will bounce, and this unit will measure that, fire that up into the cloud, and it has alert measurements on it as well. So it will send a reading to your phone to say out of tolerance. You need to get out to this immediately.
So this sits therefore on a track that we're monitoring. We've got an issue, or we've identified that the regular maintenance and the checks of this needs to do. That sits on the track.
It does, yeah.
Okay, so we've got an alert, Ben, right? So what we're going to do is now we have this crazy rig, I'm going to call it, behind us. First of all, we've got the box here. What's that? What's that do?
So this is our onboard AMU. So this works much like a total station, but with onboard gyroscopes. So it finds its position on the planet when we initialize it. And then once that's done, it will then lay a little trail as you push through, and it will pick up all your radiuses, your verse signs, and your deflection in height as well.
So you said gyroscope. Why do you need a gyroscope? Somebody like me wouldn't necessarily understand. Why do you need a gyroscope element into it?
So speed.
Oh, okay.
Is really what it comes down to. And that accuracy as well. Every time you set up a total station or set up any form of measuring kit, you can lose accuracy. This, you get your initialization correct, and you'll be getting that accuracy.
Even when you're moving, because obviously total stations that I've seen are on tripods or and basically fixed. Okay, so we need this to move. Great. Obviously we've got the wheels, the main structure, so you can do rails like the normal train tracks we see, or tram tracks, or other things like that as well, I guess.
Yeah, we go all the way down to sort of a 900mm gauge, and all the way up to a 1600mm gauge, which they have an island.
Oh, okay. So different gauges, different places. Didn't know that, folks.
Yeah.
So another thing, learning here at Railline. This looks like some kind of radiator or what on earth is this?
So
then?
this is our Z&F scanning system.
Yeah.
So it's a 2D profiler.
Yeah.
With a spinning beacon on it.
That spins around. Right?
That will spin around and capture 2 million points a second. As we push the trolley then through the site, it creates sort of a slinky effect of scanning, and that's where you get your 3D scan from.
Here, folks, we've got a target. Basically. What's that all about, Ben?
These are the standard black and white targets. So as we push through the site, we'll capture those with the IMS 5000, and then later on, you are able to pick those targets in your scan data and lock them into control points to improve your accuracy even further.
So, folks, it's all about here accuracy, 3D. It's all about safety as well. Allows us to do that work faster, therefore less downtime on the rails, therefore hopefully less disruption for people like me that want to use it. But, folks, my final bit, I'm just going to have to give it a push, Ben. So come on, let's go and do it.
So we've got the blue line here.
Right.
That's our profile points that we're picking up.
We're going to be calculating?
2 million here.
2 million, 2 million, 4 million, 6 million, 8 million. Better make sure I put the brake on, folks. Oh, we've done over 10 million points just in that one push. And I can see the measurements all been calculated in here, Ben. Wow, that is productivity for you right there. It's taken me a long time to get to it, but only literally seconds to get all that information. Cheers, Ben.
That's it. No problem at all. Thanks.